So this is the question. First I will tell you about the question. We have to calculate the work done by the applied force. Okay, so there is a applied force which is horizontal force, which is 7 Newton. So for every applied force, if any applied force are there, so there will be a frictional force. How can we say that? Because kinetic friction is there. Okay, so definitely there will be the frictional force. Okay, so after that we have to calculate the work done, like how much will be the work done by the applied force in the given time. So we know the frictional force, it always opposite will be the applied force. So let's start the question. First I'll draw the diagram that you will find it very easy. So this is your object which is kept on the table. So there is a applied force. So I'll draw the applied force which is 7 Newton. We can write this capital F. Okay, and I have told you there will be opposite frictional force. Okay, because always frictional force will be the opposite side. So we can write this small f. Okay, so this is the object. So every object has a mass, and if there is a mass, so there is always a gravitational acceleration also. So according to the weight, it will always be the down. Okay, weight of object will always be the down, which is mg. And you know the Newton's third law, that every action has equal and opposite reaction. So for opposite of the weight, there will be one force which will be the normal. So it's your diagram. So now I will write all the given points of the question, so you can find it very easy. So let's find a body of mass 2 kg. So body has a mass which is 2 kg. Okay, initially at rest. Okay, which means you have u equals to 0. Moves under the action of an applied horizontal force. Horizontal. Okay, that's why I have applied horizontal, not a vertical. So it will be capital F equals to 7 Newton. Okay, on a table with the coefficient of a kinetic friction will be 0.1. So which is mu 0.1. Okay, compute the work done by the applied force in 10 seconds. So time is also there, which is 10 seconds. Okay, so this is all our given points. So let's start the question. So first we will find what will be the normal force. Okay, so for finding normal force, N equals to mg. Why? Because both in opposite direction, so both will be equal. So we know the m, which is 2 into 9.8. Okay, so when we will calculate this, it will come 19.6 Newton. Okay, so just make a box, so it will be like clear to you. You will not get confused. So now we have calculated the n. Now we will calculate the frictional force. Okay, so frictional force F will be, we know that what is the formula of frictional force? Mu n, where mu is coefficient kinetic friction, coefficient of kinetic friction, and n is a normal force. We have both now 0.1 into 19.6. Okay, so we will calculate this one and we will find F, which is 1.96 Newton. Just make a box again. So this is your frictional force. Now we have calculated both normal and the frictional force. We will calculate F net. Okay, why? Because we have to find what will be the acceleration of a body. So for that we have to find what will be the total F net, what will be the total force on the object. So there is no vertical forces. Okay, so I will take only horizontal force, which will be F, because it's a positive direction, and minus F because it's in a negative direction. So we have both now, which is 7 minus 1.96. Okay, so when we will calculate this, we will get 5.04. Okay, this is F net Newton. So I will tell you we know that F net is always equal to the mass into acceleration according to the Newton's second law. Okay, so we can write this F net equals to mass into acceleration. Okay, so now we can write this. We have F net now, which is 5.04. We have mass, which is 2, and we can calculate A from here. So A will be 5.04 by 2. So A will be 2.52 meter per second square. Okay, so we have calculated A. Just make a box again. Okay, so now we have all the things. Now we will calculate a distance. Why we have to calculate distance? Because we have to find work done. We know work done formula is force into displacement. So we have to find the displacement. Sorry, not distance, displacement. So we have a equation, motion equation we have. So we can take S equals to ut plus half at square. Okay, so we know u is 0 because the body was initially at rest. Okay, so this part will be 0, so we don't have to write this part. It will be now half a. We have calculated a, which is 2.52, t, which will be 10 into 10. Okay, we will calculate all the things. So just I will make it simple for you. I'll draw the line that it will be subdivided, so you will not get confused. Okay, so now this is S equals to, it will be when we will calculate, so it will be 252 divided by 2. Okay, so now S equals to 126 meter. So we have S now. So now we can calculate the work done. I have told you work done equals to F vector dot S vector, because it's a vector quantity. So now it will be Fs cos theta. So both applied force and the displacement both are in same direction. Okay, so here theta value will be 0. Okay, so we know that Fs cos 0. Cos 0 value is 1. So now we have only F into S. We have both the values here. F is 7 Newton and S we have calculated 126. So 7 into 126, which is W now 882 joule, because we know the unit of the work is joule. It is very important to write all the units, because if you will not write, so you can't get the full marks. So just note, I have written all the units all the time, this and this. Okay, so don't forget to write units with that. Okay, so this was the question. I hope you find it very easy, because I have written all the things that you can understand very easy. Thank you so much.